Next example, finding the extreme values of the function on the interval. We have f of x equal x squared minus 4 over x squared plus 4. First thing we're going to do is we're going to check the endpoint values. So that will be f of negative 4. So this will be negative 4 squared minus 4 over negative 4 squared plus 4. So this is 16 minus 4 over 16 plus 4, and that's going to give us 12 over 20, which we can simplify to be 3 over 5. And then for f of positive 4, we're going to get, same thing, 16 minus 4 over 16 plus 4, which will give us 12 over 20, which is 3 over 5. Okay, so we have one set of values, and clearly I do not have enough space on here to write down what happens with the derivative, especially since we're going to be using the quotient rule there, but I'm going to record these values up here so we remember them, and we will have them available for our last step later. And now we move on to finding the derivative. Now, since our function is a quotient, we want to worry a little bit about whether or not there's going to be a problem with the denominator that would force the derivative to not exist. But when we notice here we have x squared plus 4, there is no real number we can plug in there that will make that 0, so we don't have to worry about that particular problem. All right, so now we're going to use the quotient rule to find the derivative. So we're going to square the denominator. And then we need numerator, the derivative of the numerator, so we're going to get 2x times x squared plus 4. We're going to subtract x squared minus 4 times 2x, so that's our f prime g minus f g prime over g squared. Now normally I have said do not simplify at all. Now we have to change our approach to that. We need to simplify because we need to do something with this. So I'm going to go ahead and distribute, and then we're going to simplify as much as we can in the numerator. So distributing in the numerator is going to give us 2x cubed plus 8x. Then we're going to subtract 2x cubed minus 8x. And then when we go ahead and distribute there and simplify everything, the 2x cubed minus 2x cubed will cancel. We're going to get an 8x plus 8x. So that's going to leave us with 16x over the quantity x squared plus 4 squared. Now we don't have to worry about the derivative not existing because the denominator will never be 0. But when we set this equal to 0, all we need to worry about is what happens with the numerator. So we're going to get 16x equals 0, which means that x is 0 is the critical number. All right, so our next step in our process, in our steps to find the absolute max and absolute min values, we're going to take this x equals 0, we're going to plug into the function, not the derivative, but the function. So we're going to get f of 0 is equal to negative 4 over 4, so this gives us negative 1. And now, choosing out of all of our function values, so that is our negative 1, and then our positive 3/5, which we got twice there. Our absolute max value is the largest of those. So in this case, that will be 3/5. And our absolute min value is negative 1.